Guys, please welcome JoshLong on Java Conference 2023. Hi, Josh.
Good morning or evening or afternoon. I don't know. That's like
We have people all around the world, so yeah, anything will be perfect. Hi. How are you doing?
good. Thanks for having me here. I'm super excited. It's nice.
Yeah, we are excited as well. So, guys, we encourage you to ask your questions. I remind you that we have two chats, one in YouTube, one on our platform. You can ask questions in both of them. We will try to ask all of them in the end of the talk to Josh. So please share your questions, share your comments, share your thoughts during the talk. Everything is can be in place. So I think we should not spend any more time. I would ask Josh to share his screen, and after that, let's start.
Okay.
Also, yeah. So let's do that.
Let me see. Okay. I'm gonna present. Share my screen. All right. Entire screen. Go. Share. Haha. Okay. Very good. Hi. My name is Josh Long. It's very good to be here with you. It's 9:10 in my time, local time. So what do we have? 45 minutes, an hour, 2 hours, 7 hours? What's the
We
budget?
have an hour, but you can have as much time as you want.
I'll try to stick to an hour. My name is Josh Long. It's very good to be here. Like I said, I work on the Spring team. I'm a Kotlin Google developer expert and a Java champion. And I'm just really happy to be here with you all today. I love I love virtual conferences. I love online content. If you don't mind a shameless plug, I have a YouTube channel there, youtube.com/coffeesoftware. It's not terrible. It's not. And by the way, we're using a StreamYard for this, which I also quite love. I use it all the time. It's a good choice. So anyway, I work on the Spring team, and my friends, it's November 17th. And you know what that means? Actually, I forgot to tweet that. There are what is it? 7 days, right? So it's November 17th. We release on no, 6 days? On the 23rd. 6 days until Spring Boot 3.2 GA comes out. Okay, that's awesome. So good stuff, right? We've got that. There are 6 days. That's amazing, right? We're an amazing time. Spring Boot 3.2 comes out next week on Thanksgiving. In the US, we have the holiday of Thanksgiving. It's a great time of the year to be thankful, and I am thankful for this release. You see, I think we are in a point in our history where we can say there's never been a better time to be a Java developer or a Spring developer, right? There's never been a better time to be a JVM developer, and I say that fully aware of where we sit in the scheme of things, right? If you look at the history of things, right? So if you go here, spring1.io, history of Spring, we have a little video game you can play. It's this year we celebrate 20 years. So we can look at the history. Rod published the first book in 2002, 2003. We had the first early access builds of something called Spring, and then 2004, Spring Framework 1.0. And then, of course, you can keep going. And if you go real fast, all the way over here. Come on. You get over here, and you can see now towards the 2015 era, we get Spring Cloud. By 2014, we had Spring Boot. 2013, we had the first early access builds of Spring Boot. So it's been 20 years of Spring Framework and 10 years of Spring Boot. And just keep going all the way over to the end. And you can see it's just been an amazing journey, right? And I say that there's never been a better time to be a JVM and Spring developer. I say that knowing that this year we mark 20 years of history, right? It's an amazing time. And that's just, it's hard to overstate that. So like I said, next week we're going to celebrate Spring Boot 3.2. It's going to come out. This release is huge, and it builds upon the 3.x sort of generation of software, the 3.x Spring Boot line, and there's just some amazing stuff there. So my friends, let's just take a look at that. We're going to go to my second favorite place on the internet. Obviously, my first favorite place is and has always been production. I love production. You too should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. And my friends, we're going to build a new piece of software. So I'm going to use Java 21. So for the moment, just for the moment, things are a little loosey-goosey with Gradle. So we're going to use Maven, okay? I had a New Year's resolution this year. I still have it, but it's just not going so well. My New Year's resolution, I had two. One was to lose weight, and two was to learn Gradle. And anyway, the Gradle is going well. It's going well. I'm definitely learning Gradle. But anyway, for now, we're gonna use Maven. Okay, I like Gradle, but it doesn't quite work with Java 21, so we use Maven. Then we have to choose the version of Spring Boot. We're gonna use the latest and greatest. But again, 3.20 RC2 will be GA, and again, when? On the 23rd of November. So just a few short days. Okay, next Thursday, actually, next week. Minus 1 day, right? Next Thursday it'll be GA, and that'll be wonderful. And then we have to choose what we want to name our software. Friends, I'm going to name it Service. And the reason I'm going to name it Service is because I'm really, really good with names. I get that from my father. My father was also really good with names. We had, when I was a small boy, we had a small white dog, and my father named this small white dog. He named it White Dog. Now, this dog was with us for like 10 years, and I don't know what happened to him after that. I think maybe he got a job or something. I don't know. He disappeared. And then suddenly, magically, we got another small white dog, and my father named this small white dog Too. Now, I'm not sure if it's T-O-O or T-W-O or what, but either way, great with names. I get that from my father. My mom, however, she tells me all the time, she says, "You're very lucky that I named you," and yeah, that's probably true. So, okay, we're going to call this Service, and then, of course, we're going to choose Java 21. Friends, you have a number of different choices here. You have 4 different radio boxes, but friends, there are only realistically 2 valid choices, and really, if you think about it, only 1 really valid choice. You see, in order to use Spring Boot 3.x and later, you need to use Java 17 and later. So these other 2 radio boxes, these are just for the memes, just for the lulz, just to find out who makes terrible life decisions. You should never select these versions of Java ever in any context whatsoever. These are completely unacceptable, except to show people, ironically, what they should never do. And I think you should be using Java 21 because, as we'll see, if you don't use Java 21 and you don't take advantage of the features in Spring Boot 3.2, you're just burning money. If you don't like money, then by all means, use Java 17. But if you do like money, then use Java 21. I think the choice is pretty clear. And I think, these are technically amazing releases. Java 21 is technically superior in every way compared to Java 8. It is syntax rich, it is robust, it's operations friendly, it's secure. It is technically superior in every single way compared to Java 8. It is also morally superior. You won't like the look of sadness and despair and shame in your children's eyes when they find out that you're using Java 8 in production. So don't do it. Be the change you want to see in the world. Do the right thing. I'm going to use Java 21. And by the way, if you're not already persuaded, then I think we can all agree, just judging purely by the version number alone, that Java 21 is greater than Java 8, okay? Almost 3 times greater. So we're going to add some dependencies. We're going to use the GraalVM-native image support. We'll use DevTools. We're going to use the Testcontainers support. We're going to use Postgres. We're going to use the web support. We're going to use the JDBC support. I hit enter by accident. Let me clear that up. Okay, good. What else do we need? JDBC, web, Postgres, Testcontainers, GraalVM, DevTools. I think that's it. I think that's enough for now. Okay, so and maybe we'll bring in the actuator as well. That's fine too. Why not? Okay, so good. So we're gonna go ahead and I'm not even sure if we're gonna have time for this. Let's try. Okay, we'll try. So I've got a new service. I'm gonna hit generate. I'll open this up in my IDE. Let's see. Here we go. And it doesn't matter what IDE you use, so long as it supports Java 21 and Maven, which of course all do. By the way, for those of you using Visual Studio Code, did you all see the new Oracle Java Platform Support extension that provides? It's basically the NetBeans editing experience packaged up as a Visual Studio Code language server, which is super good, right? That's super cool. So now instead of having to download 5 different plugins from Microsoft and Red Hat and all these other wonderful organizations, you can just get one unified experience inside of Visual Studio Code. It's pretty good. I like it. Okay, so we have a new application. This is our production code. But friends, we're not going to start here. You see, I want to live that git clone run lifestyle. I want to be able to take my code, git clone it, and then start making changes to it immediately. And to that end, in Spring Boot 3.2, we have added, 3.1 back in May, we added new support for test containers and Docker Compose. And the basic idea here is that when we went to the initializer, it code generated for us in our source test Java code here, source test, not main, test. It code generated for us a Java configuration class with extra bean definitions and a public static void main method. So this is a main class, just like the one in the production code, but it's good for running during development. And we're going to run this, and what it's going to happen is it's going to start up the application, and each time it starts up the application, it's going to also find the extra test configuration here, Java configuration that you've seen before, and register those beans as well. And these are only useful during development. One of those beans is a Postgres test container. Test container is a Java API for working with and standing up Docker images from Java. So this bean, when it gets created, is going to call the Docker daemon and then do Docker run Postgres :latest for us, which is great. But that's a little bit problematic because remember, I want to move quickly. I want to go fast. And if I make a change to my code, I'm going to then restart the code, and it's going to restart the Docker image. I don't want that. So instead, I'm going to use dev tools, which is a great way to make really quick changes without having to do a long restart. But I don't want to wait for this. So I'll tell Spring to not restart that on every single dev tools build. I'll use this @restart scope annotation. Okay. So now let's go ahead and run just this class, public static void main, in the test code, right? During development, this is very convenient because what's going to happen is we're going to start up the Postgres container. You can see it's starting there. There's the Postgres Docker image and all that. And then we automatically created a URL for you for the data source. That's what this @service connection annotation is doing for us, is identifying this as a thing to which we can automatically connect. And by the way, that if you don't know much about Spring auto configuration, what normally used to happen is you have a class that starts up when the program starts up, and it looks at the environment and it registers beans. One thing that we used to do, is we take properties from your environment or your property files or whatever and map them to Java objects. And then, so, spring.datasource.url becomes a variable that's of type URL on a object that has the prefix spring.datasource, right? And so it's pretty natural. It's a type safe way of moving properties around. And then in our auto configuration, we take that properties object and then use it to create, let's say, a data source, a JavaX SQL data source or a Jakarta SQL data source or whatever. And that's worked fine for years and years and years, like 10 years, right? But in 3.1, we changed things a little bit. Now, we create, from those properties, we create something called a connection details. And then from the connection details, then we create the actual data source. Why the extra step? Well, now we can create connection details from other things besides just properties. One of the things that we can create it from is Docker instances, Docker images being run in the Docker desktop or Docker daemon, right? So we can actually automatically connect to that instance and get the credentials from there, right? They all export their credentials for you to use. So now I don't have to specify Spring data source URL and Spring data source username and Spring data source password. Same thing for MongoDB and Cassandra and all these other things. I don't want to have to specify credentials when the Docker image already has that. That's what this annotation does. And by the way, that connection details, it's a hierarchy, right? It's a hierarchy of types, but it's kind of funny to me if you look at the actual interface, the marker interface, because look at this interface. You can see it's very complex, very, very complex, but yet look at the author text. There are 3 authors here. I don't know why. I'm just wondering what happened in this discussion that meant that 3 people had to be involved. But anyway, it works. And by the way, like I said, it's a hierarchy. Okay, so it might have just been that they refactored the code out of there and it got moved to other places. Okay, so we've got this public static void main. We've got our database. We're already up and running. This took a long time. Remember, we had to start the Docker image. It took a long time. But we don't have to worry about that going forward. So now what we're going to do is we're going to build a data-centric application. I'm going to go to here. I'm going to create a schema file and a data file. So schema.sql, create table, if not exists, customer, ID, serial, primary, key, name, varchar, 255, not null, okay? And then data.sql, and I'll say delete from customer, and then we're going to insert some data, just some sample data, so that we have something with which to work. Say, Josh, hi, I'm on the Spring team. Who else is on the Spring team? We've got Jurgen. Oh, nope. That was the wrong accent, my friends. Don't do that. There you go, Jurgen. We've got Madura. We've got Olga. We've got Violetta. We've got Yushin. We've got Stefan. Sorry. We've got Spencer. There you go. There's 8 people. Okay, so we've got now 8 names in the customer table. The table is called customer here. And now I want to tell Spring Boot to automatically run these SQL files when the application starts up. So I'll say SQL init equals always. Okay. Now I want to build an application that actually uses that data, and so I'm going to create a simple record here. Okay, so record integer ID string name. Now this is a record. I love records. I love these so much. I mean, this just makes life so much simpler. The basic promise here, the basic contract here, is that Java basically is a very simple language, and in Java we have this new thing called a record, which is basically what other languages call tuples. The thing is, in Java, everything has to have a name. It's a nominal language, right? And so in Java, we don't just have unknown anonymous tuples. We call them records. They have a name, right? But they have the same contract as a tuple. They're a sequence of variables of whatever type that we can stash there, and whose identity is equal to the identity of the constituent variables. And when I say variables, I mean the components that are passed into the constructor of that record. So the ID and the name. The identity of customer is equal to the identity of ID and name, okay? And records, if you agree to this contract, then the language can do some amazing things for us. It can give us accessor methods. It can give us 2 strings and equals and hash code and all this other stuff that you get for free just by using a record, right? So it can do that because it makes that contract with us. And it also knows how to unpack one of these objects. It knows that in order to make another customer, we just need an ID and a name, right? And so it also knows that if we want to like extract out variables, we can extract out the state of the object by extracting out those components, these constructor components. Records have a lot of depth, and actually they enable 1 out of 4 big features that are in Java 21, which is what we're using here, that the Java language team is calling data-oriented programming, right? And the idea here, friends, is that in Java, historically, Java has been very dominant. It has succeeded in the era of the monolith because it's very type safe. It's got good package privacy protection and access controls, and it's very easy to create nice, clean, object-oriented hierarchies. And this is great in a monolithic application where you have large, deep-seated hierarchies of types where the dispatch is in terms of implementations, polymorphic implementations of those types. That's dynamic data. That's dynamic, dynamic dispatch, right? That's a very common precept of object-oriented programming. But increasingly, friends, as we move into the era of the cloud and small, singly focused individual microservices, we're not building deep-seated hierarchies of abstractions anymore, right? We're not using dynamic dispatch anymore. Instead, we're using things like messages. We're sending messages across the wire from one side of the program to another and from one program to another. And that is data. The way we communicate, the way we express change in a system is now in terms of the data that we conduct through that system. And so the language naturally has to evolve to support these kinds of data-centric use cases, right? And the language has, and it has 4 huge features. We have records, which we just looked at, right? Sealed types, right? And then, of course, pattern matching. And then, of course, this smart switch expression, right? These are all things that taken together support data-oriented programming, and it just comes together in Java 21, which is a huge deal. So let's just take an example here very quickly here. So imagine I'm working in a highly regulated organization, and I've got a type called a loan. Well, loans are, they're monetary instruments. They're heavily regulated in lots of industries. It's very important that when you have a loan type in your code, that you handle all use cases consistently, right? You don't want people just creating new anonymous subclasses of loan and then passing them through to make something work. You have to make sure you're handling all the cases correctly, right? So you want the compiler to help you. So I'm going to say that this is a sealed type, okay? And I'm only going to permit 2 specific subclasses. And maybe that subclass is sealed loan, implements loan, okay? And then not sealed, secured, right? Secured loan. We're going to say secured loan and then unsecured loan, right? So we've got 2 different types. I'm going to explicitly permit those loans, unsecured loan, etc. And so now the compiler is saying, okay, look, you want me to guarantee that there are only 2 implementations, but this class is still public. It's still not final. So I can either make it final, in which case that gets better, or I can make it sealed as well, right? Or I can make it a record. But either way, I need to guarantee the compiler that I'm not going to change these subclasses. There, now everything is happy. The language knows what sealed types we have. It knows that these types are as many types as we've got. And this is a new kind of access control, right? These types it's not just public or private or package private. It's a new kind of visibility, which is it's sealed or not, okay? So good, so this is better. Now, imagine that my secured loan, the interest rate is gonna be very good. It's fixed, all the good interest rates, all the good applications get really, really good loans. It's all the best. They get the same rate, okay? But what about the unsecured loan? Well, this depends on credit history, right? This is going to be very different. So let's imagine that this is actually a record, and we've got some state here, okay? So it'll be float interest, okay? And now let's say I want to build a message based on those loans, okay? So I'll have a method here, display greeting for user loan, okay? And I'll pass in a type of loan. And I could do something like this. I could say, okay, if loan, instance of secured loan, well, then I have to downcast. I can do that like this. I can say secured loan and then loan, and then I can say, okay, return, good job, nice interest rate or something like that, okay? And then I can say, okay, if loan, instance of unsecured loan, then I can say var USL unsecured loan equals loan, and I can say, ow, that USL dot interest is going to hurt, right? Something like that. I don't know, whatever. Imagine a very cruel bank, right? So this kind of works, but it's kind of ugly. So let's use our first taste of pattern matching. The first thing is we can actually unpack this. We can say secured loan, and we can use this. We're identifying with pattern matching. This is the matching phase. We're identifying that this is a type that can be cast down to that. And then we're extracting by creating a variable so that in the context of this if statement, we can say that this variable is definitely castable, okay? And I can do the same thing down here, okay? So let's do USL, there we go. So now this code is definitely castable within this context, within that scope, and so it's easy to work. But still, this is a little bit flawed, right? Like I have a default case here, I guess, but why do I need one, right? I've only got 2 objects. Why do I need this? And I need it because the language, it doesn't know that that's all that's going to happen. The other thing is, what happens if I get rid of this? Well, now I'm not handling all the cases, am I? Right? I'm only handling one. Does the compiler care? No, it doesn't. So I've got this unnecessary default case. And in this case, if I comment went out, I'm not even handling a case. And the compiler hasn't helped us out at all. So one way to get around this is to switch to smart switch expressions, right? Get it? Switch to. So I'm going to switch on the loan type itself, not an int, right? Not an enum, but the loan type itself. And I'll say, okay, case unsecured loan, right? USL. Then we can return this. Good, look at that, okay? Look at that, I can return an expression from each branch, no need for a break. And then from this one, I can say secured loan, SL, and I can return that, okay? So here, there we go, good. So now, well, first of all, I don't need this, it's extra, good. And now the compiler's happy, I'm still using pattern matching, but what if I don't cover a case? Okay, wow, the compiler's saying, hey, you didn't cover all possible input values. So the language is making it cleaner to do what I'm doing, and it's making sure the compiler yells at me if I forget to handle a case. This is super good because that means it's not possible to not handle a particular branch. And you might say, oh, well, I can use the visitor pattern, but that's just it, right? That only works if you know all the known states of the instance of the type. But if you forget to account for that, then you're going to miss a branch, right? This is the compiler helping you, and it's actually very clean it looks, it's much better than a regular switch expression. So, okay, so we've got now pattern matching. You saw our first taste of that, but even this, I'm dereferencing the unsecured loan just to get access to the interest. Well, remember, unsecured loan is a record. The state of the object is the components of the object. So I can actually extract out that interest into its own variable and dereference that directly. I don't need the container, right? There you go. So the language is now doing smart pattern matching based on these, and you can even do when branches. You can say, okay, when the interest is equal to this, then extract it out or whatever, right? So there you go. I've got now a nice message. I've got sealed types. I've got records. I've got smart switch expressions and pattern matching. These things make it really easy to build services with messages, with data. And this is increasingly what you'll see when you build microservices, right? Ad hoc messages coming in over the network from Kafka or REST or whatever. These are stringly typed messages, right? And the language is now built for this kind of stuff. It's really, really elegant to deal with this kind of data-centric processing. Good stuff. Okay, so even though I used a record here, remember, this is just the beginning. Okay, we are just looking at the very beginning of the possibilities here. The next thing I want to do is I want to build a repository to talk to that, right? So I'll build a customer repository. Okay, and here I need to talk to the database. Friends, one of the new things I can talk about in Spring Boot 3.2 and Spring Framework 6.1 is the new JDBC client. Now, if you've ever used Spring's famous 20-year-old JDBC template, right? This thing has been here forever. This type is how a lot of us got into Spring. This is how I got into Spring. It's a way to just use regular JDBC. Well, look, it was written in May 2001. This class is 22 years old. Closer to 23, right? It is a very, very old class, and it is amazingly useful, and it's been around forever, and it works really well for like 99% of the use cases, and all you need is a data source, right? So a lot of us, like me, I started using it in 2003. I started using it just to bring this class in. I didn't even get a chance to use the rest of Spring, but this was so useful. I was like, I need this. But the problem is, this is like super useful 99% of the time, unless it's not. In which case you end up in one of these overloaded methods that has like a million different parameters and that you kind of have to do all the work yourself. If you find one of the overloads that does exactly what you want, then it's beautiful. But if you find something that isn't accounted for, then you end up doing a lot of work yourself. Well, we want something where it's like more granular. Instead of like 100% or 10%, what if you could just add 10% each time, right? You can compose more granularly. And so that's what this JDBC client is. It's a fluid DSL style API for working with JDBC, but it has a lot of the same types as you would have from the JDBC template, including the row mappers and the row callback handlers and the results set extractors and all that stuff. It's got the same types as you're familiar with from the JDBC template, but it's a fluid DSL style. If you've ever used any of the reactive stuff, you might recognize the R2DBC database client, right? Very similar style, but this doesn't use reactive. And we'll talk about why that's not a big deal in a bit, okay? So let's create a method here, okay? I'm going to create a method to return all of the customers from the database. So customers, okay, like that, return this.jdbc.SQL, select all from customers. And by the way, this is another thing that's in Java now these days that wasn't there before, and it just feels so much better now to use straight SQL, right? Now look at that. So select all from customers, and let's see, I want to do a query. I'm going to do a query with a row mapper, so I'll say RSI and new customer rs.getID, rs.getString name, okay? I'm going to turn this into a list and return that. So now I've got a very simple query that just returns all of the records and then maps each row into an object. And you can see how nice it composes, right? I can actually just reuse this too, because maybe I want to put that up here and then reuse that lambda to map other results from the customers table. So what else might I do? Well, maybe I have customers by name. Okay, and I can say string name, return this.jdbc.SQL. Okay, and I can say select all from customer, and by the way, it's customer, not customers, where name equals this, param name, query this.that, and then list, right? Good. So now we have our simple methods to return the results. Good stuff, right? We did it. Good stuff. So now we have these two repository methods. Maybe I want to build a simple controller to talk to that, okay? So create a response entity, response mapping, customer controller, very good. And I'll use that here. I'll say private final customer repository. Inject that into the constructor, and I'll say at get mapping customers, right? Collection of customers. Turn this dot repository find all. Whoa, hey, come back. There you go. This dot repository. Okay. Dot customers. Good. So let's actually try this out. So do I have the program running? I do. So I'm going to make a change. I'm going to do Command Shift F9. I just did rebuild. That's this right up here, right? Command Shift F9 is recompile. And you can see the original, when I started it several minutes ago, it took 2.4 seconds, which is an eternity. Nobody has that kind of time. This time it took 0.3 seconds, right? So it didn't have to, it's almost an order of magnitude faster to do DevTools reloads than it is to do actual reloads, right? Because we don't have to restart the JVM, right? And we don't have to restart Postgres, which is also very good. Okay, so now let's try it out. Customers. It's saying we don't have select all from customer. We don't have that table type. Oh, because of the, I think it's because I changed this and it's not getting picked up. Okay, so let's fix that. Restart. Okay. And customers, it's saying select all from customer. Well, what's the issue here? Schema.sql, customer, data. Okay, and okay. And then application.properties. I feel like I did everything right. What did I do wrong? Source main resources, data.sql. Select all from customer. Select all from customer. Oh, there. Sorry. Command Shift F9. And now it's saying the view result. Okay, now I have to make the controller correct. So we go over here. Where's my controller? At response body. Command Shift F9. Take that again. And there we go. Whew, okay, so we have our data. Now we have our HTTP endpoint. I want to create another endpoint here for the names, right? Get the customer by their name. That's easy enough. So we'll do that here. Customers by name, path variable string name. And then we'll just say by name. Okay, Command Shift F9. Go here, Josh. There we go. It's worked. Great. We're moving quick. We've got our data in the database. We're using data-oriented programming. We've got nice fluid DSLs to get super fast, efficient performance. By the way, you could still use an ORM. We have Spring Data JDBC. We have all these other things, but you can use whatever you want. I just like the low-level JDBC client a lot, so I wanted to show that to you. Okay, so we've got our simple data access. We're talking to the database itself, but what if we have data somewhere else? What if we want to get some facts from another API, for example, okay? Well, there's a couple ways we could do this. One is we could just build the client ourselves. Let's say we're going to build a cat fact client, okay? Uh-oh, I heard my dog walking around. He's offended that I'm going to talk about cats. So we're going to inject here the the REST client. This is another new thing inside of Spring Framework 6.1, and it's the same kind of use case. We have the REST template, but sometimes it feels nice to have these fluid, composable DSLs. So we have this instead, and we have to define this bean. Now, friends, here's a pro tip. When you create the REST client, inject the builder like this, and then use that to specify the request factory, because the default to retain compatibility with the REST template, the default is to use the old request factory, which uses the Java Net URL abstraction, which is a very old client. It doesn't even support options, right? So instead, we're going to use the java.http JDK client. That's the new one, right? And this is much better. So specify that. Now I've got the REST client. I'm going to inject that here, and I'm going to make a call to a web API called the Heroku Cat Facts API. Okay, go here, and here's the documentation, and it's just that URL. Okay, and we're going to say, okay, record cat fact. Okay, string text. We're going to insert that here. Collection cat fact facts. Good, and then we're going to say return this dot http dot get dot uri dot facts dot retrieve dot to entity new parameterized type reference of collection of cat fact. Okay, so there's this, and actually we don't need the two entity, do we? We just want the result. So we'll take that to body. There we go. Okay, there we go. So that'll give us a collection of cat facts, right? That we're going to return. And actually, it knows by it knows the type there, so we can just do that there. So now we're using the new Fluid DSL, and again, same thing. You can use a lot of the same types that you used from the REST template. A lot of them here, like the message converters and HTTP message converters and things like that. Those all work as well. So let's now try this one out. Let's create a cat fact controller. Okay, at controller at response body cat fact controller. Okay, cat fact client. Cat fact client. Okay, that, and we're going to say git mapping facts collection cat fact. Okay, return this.cfc.facts. Okay, so now Command Shift F9, go here, localhost facts, and you can see it's made a call to the service, and we got the results back. Fantastic. Okay, now think, this is pretty good. I like this, but this took a lot of work. I had to write all of this code, right? This cat fact client. Another new thing we have in the Spring Boot 3.0 line is declarative interface-based clients. Now, so we can actually just reduce this down to one simple interface. We're going to say interface cat fact client, and we're going to take a method here, collection cat fact facts, and I'm going to use the get exchange annotation, and we'll just pass this URL in. Pretty simple, huh? So do that, and then we can delete this code, and we have to define this interface as an actual bean, and we can do that now using a generic mechanism, and this works for RSocket as well, so you can do all sorts of stuff. So we're going to say HTTP service proxy factory dot builder dot build dot create client cat fact client dot class, and we need to specify the builder and the exchange adapter. So it's going to be a JD REST client adapter dot create, passing in this REST client that we just defined earlier. Okay, so pass that in. There you go. Okay, so now we've got this chain of things, but we're basically saying create an actual bean out of this interface that we can use. So let's go ahead and reload the configuration again, make another call. There you go. You can see the same exact functionality, but we didn't have to write the client, right? Much better. We're still using the controller, of course, but the client itself is done for us. Okay, so now, what are we doing when we make that network call? When we make that network call to the Heroku service, what's happening? Well, we're waiting, aren't we? This behind the scenes, this is using input stream and output stream to make the request. So when we get the input stream and we call input stream.read, we're waiting for the next byte to arrive, waiting for the next byte to arrive, waiting for the next byte to arrive. How long does that take? We don't know. Hopefully you've specified a timeout, but there's really no way of knowing how long that's going to take. And that's okay if you've only got low traffic. But if you have, a high enough number, you're going to run into problems, because for every single request you make, you're making that request on a thread, and that thread is no longer available to anybody else in the system, right? This is a big problem because you're wasting that time on that thread. So let's take a look at an example here of what I mean. And this is an example from my friend Jose Pomar, Java Developer Advocate at Oracle. I'm stealing it blatantly and brazenly and unashamedly from him. I'm sure he would be okay. But let's just take an example, okay? Threads, okay? Let's just see an example here. Return new this, and merci Jose Pomar. Okay, there we go. So we're going to create a bunch of threads here. Okay, threads. New array list of thread, and we're going to say for var I equals 0, I is less than, let's say, 1,000, I plus plus, and then for each thread, var index equals I. I have to create a local variable for each thread. For each number, I'm going to say threads.add, and I'm going to create a new regular platform thread. I'll say thread.of_platform.unstarted new runnable. Okay. And then I've got now 100 or 1,000 threads, right? That's what that is, 1,000 threads. And in this thread, we're going to do some work and we're going to waste time. Okay, let's talk about that in a second. But before that, once we're done with all that, I'm going to go through and I'm going to start each thread. So I'll say threads.start and then do a join to make them all wait until they finish. And then I'm going to print, and then when I'm running the program, I'm going to take notes. I'm going to note the current thread name. And I'm going to put it in a list, so in a set, so that it'll be deduped, right? I won't have duplicate records in there. So I'll say concurrent skip list set. And then when I run the program, here's what I'm going to do. I'm going to do thread.sleep 100 milliseconds. So I'm going to waste time. This is just like calling input stream.read. And then if I'm on the very first thread of the 1000, if I'm on the first one, and it could be anything. It could be, if I'm on the 50th one, it doesn't matter, but I'm going to just do one. If I'm on the first one, then I'm going to add the thread name. Okay, so current thread.toString, add that there, and then I'll do this again. So I'm going to copy and paste this code. Terrible idea, right? I'm going to do something terrible, something that you should never ever do ever. Not even when you're all by yourself at home and no one is looking. I'm going to copy and paste code. So what I did is I'm sleeping for 100 milliseconds, and then I take note of the current thread name. If I'm the first thread, I sleep another 100 milliseconds. That's 200. Take note. 300. Take note. 400. Take note. So I'm sleeping 400 milliseconds, but I'm creating 1,000 threads, right? Operating system threads. And so now I want to take note of that. I'm going to write out what we observed. Okay. So let's go ahead and rerun this program here again. And you can see that in the life of the program, it was on this thread the entire time, which is bad, right? And this is going to become a big problem when we start maxing out that number, right? 1,000 threads, okay, fine. But what happens if we get 10,000 or 100,000? Well, as soon as we start doing that, we're not sharing, right? We're not giving up that thread for anybody else to use when we're making those requests across the network. And we're going to run into a thread starvation issue, right? So this is a big problem. So now let's instead of using regular Java threads that we know and have used for 20 plus odd years, 27, 28 years, instead, let's use this new virtual threads in Java 21, okay? Virtual threads are amazing. So I've made this 100,000. Let's go ahead and restart, okay? Restart the program. And you can see the program is finished already running, but you can see here that same code. Look at that. I added, 10 times more threads, but now it says it ran on the virtual thread 1267, virtual thread 1267, virtual thread 1267, but the threads themselves, the actual operating system thread, changed. It automatically changed after each blocking operation. So behind the scenes, we were running on one thread here. It then detected we were running on one thread here. It then did a blocking thing. The runtime moved us off of the thread, put us into RAM until the blocking thing, like input stream and output stream.write and read and thread.sleep, it waited for that thing to finish, and then it put us back on another thread. That first thread that we were on here on line 63, that one is now busy doing something else. So it had to put us on a different thread. That's why the name of the thread changed. It does this automatically behind the scenes for us, right? We didn't have to write. You didn't see me launch any threads here, did you? Like I didn't change the thread. There's no change to available thread or something like that, right? I didn't do anything like that. It just did it, right? That's amazing. And what that means is now I can have millions of virtual threads, but I still have the same number of actual operating system threads, but that's okay because I'm not wasting time on them. If I'm making a call to that Heroku service using my declarative interface-based client, I'm not sitting there wasting time. This is super valuable because now I get much better scalability. The same machine, the same code base that I had before, all I gotta do is change the kind of thread I'm using. And of course, this is pretty low level. Remember, friends don't let friends write threaded code. You don't need to write code this low level. If you're going to use threads, first of all, you're probably not going to use thread.virtual. You'll probably use an executor service, right? This is what a lot of people do, is new virtual thread per task executor. This is the new executor in Java 21. It is not even a thread pool. It's just going to create new threads all the time. And you can use that just like you would any other executor service to submit the task. But even this is low level. Remember, we shouldn't be dealing with threads at all, right? This is too low level an abstraction. How many of you know Tony Hoare, H-O-A-R-E? Tony Hoare is he's the person that came up with the idea, the notion that null was a $1 billion mistake. And I think he was wrong about that. Obviously, PHP was the $1 billion mistake. But he also talked about threads. He said in the 1970s, by the way, he said threads are considered unsafe, basically. They're not a good way to build scalable concurrent systems. They're unsafe. They're dangerous. And he was right. That's 40 plus years ago. And he was right. And here we are still using threads. So let's not do that. I mean, most of the time we shouldn't be dealing with threads at all. If you're going to deal with threading, if you want concurrency, use a framework, use a system on top of that, like actors or sagas or reactive or whatever. But if you're going to use it, at least it's nice to know that this is very, very convenient. But again, most of us aren't going to use threads at all. And if we do, we'll start with this. But the thing is, in your typical Spring application, there's lots of places where you might have executor services, right? Your web container, your integration layer, your data. I mean, all these different things might have executor services, your Spring batch code, right? All this code might require its own custom executor service. So friends, I don't want this executor service. I don't want to have to configure this all over the place. So if you're using Spring Boot 3.2, which comes out when? You're right, next Thursday. Good. If you're using Spring 3.2 and Java 21, just specify Spring Threads virtual enabled equals true, and we will do the work for you. So now, everywhere in the platform, everywhere in Spring that you could be using a thread pool, a virtual thread pool to get this amazing scalability, we'll just do it for you. It just happens for free. So now Tomcat, now that declarative REST client, all those things where you could be blocking a thread, it's now doing a virtual thread. So it's basically free. You're not wasting time on the thread. The thread is able to handle other work in the system in the meantime. Isn't that amazing? Okay, good. So now we've got our declarative client. We've got our JDBC client. We've got our data access layer. We're moving to virtual threads. Make that a Lambda. That's much better. Good stuff. We got free, easy virtual threads. I think and we got our controllers. We got our all this kind of stuff. I think it's time to talk about moving this thing to production. And friends, here, what I want to do is I want to package the application up to be as efficient and production worthy as possible. And friends, it's worth mentioning, if you have a question about how to package an application for production, then of course you're going to use build packs. What is this? Buildpacks.io, all right? Cloud native build packs. This is a way to containerize your application. And it works with Java applications, .NET, Ruby, everything, right? Remember, friends don't let friends write Docker files. Don't do it. Use build packs. This is a super easy way to do it. There's a CLI that you can use if you want. But if you're using Spring Boot, you don't even have to use a CLI. You can just do Maven Spring Boot :build -image. Or if you're using Gradle, you can say Gradle W build boot image, and that'll create a Docker image for you out of your application. You don't have to configure anything else. It's already there using build packs. Now, I'm not going to do that because this is not new. I just want to point that out. Build packs are awesome. They're just a much better way to take an application and get it to production without having to worry about the pain of writing a Docker file. Because by the time you finish writing that Docker file, it's probably already got a security vulnerability. Don't do it. Use build packs. It represents the collective wisdom of tens of millions of deployed Java processes over more than a decade's time between Cloud Foundry and Heroku. So it's a much better choice. Okay, so now the next thing is I want to make my application as small and efficient as possible. And friends, it's worth taking a moment here to appreciate just how amazing Java already is. And I think this is typified by this great blog here that was on the New Stack in 2018, before the COVID pandemic, or BC. And this blog asked the question, which programming languages use the least electricity? And you can see here that the results are pretty telling, right? If you look at this table, comparing energy, for example, you've got C, and C is the most efficient for machines, not for people. Not for people, just machines. It's the most efficient for machines, okay? You've got Rust, zero cost abstractions, good stuff, well done. You've got C++, disgusting, moving on. And then you've got Ada, who cares? And you've got Java, and Java's 1.98, but let's call it 2, okay? 2.0. So we're gonna, just simple math, 2.0. So we can say Java is twice as inefficient, right? Or more, or better, C is twice as efficient as Java. Okay, same page, everybody. We all agree. So 1 is 2 times less efficient than the other. Okay, good. We've got other entries in the list. We got Swift, we got Haskell, you got Go, Away, you've got JavaScript and TypeScript. By the way, how is JavaScript like 4 or 5 times worse than TypeScript? I do not understand this. How? Anyway, moving on. You got these disgusting languages, not talking about them, and you got JRuby. By the way, the Ruby implementation on top of the JVM is almost a third more efficient than the C implementation of Ruby, right? The JVM is amazing software. And then of course you've got this, and this really hurts me. I love Python. I use Python all the time. I've been using it since the 1990s. I'm a huge fan. And yet this number is also problematic. Like, it's really bad, especially when you consider the rise of AI, right? Like, think about this. This is 76, and that is 2, right? 2. So 76 divided by 2, right? I'm not great at math. You know who is great at math? Python. So 76 divided by 2, that's 38. So that means that if you wrote a program in Java, and then that program, if that program used a little bit of electricity, and that electricity came from a factory that created carbon that went into the atmosphere, and then it went and trapped a little bit of heat in the atmosphere, and that killed 1 tree, then the equivalent program in Python would kill 38 trees. That's a forest. Like, that's way too many trees. You know what I'm saying? Like, that's a big number. We really need to kind of understand what that is. That's worse than Bitcoin, right? That's just super bad for everybody. So anyway, I don't want to talk about that too much. I'm just saying Java is really, really, really good. It's already very good. But the question then, of course, is how can I make it more efficient? There are 2 ways to do this. One is, if all I care about is startup time, right? Then one effort I can use is Project CRaC, right? Coordinated restore at checkpoint, right? Coordinated restore at checkpoint, right? Introducing. So there's this one right here. And Project CRaC is a really good way to take a snapshot using CRIU, C-R-I-U, which is a Linux technology. It's a great way to take a snapshot of your Java program, and then when the program, you take a snapshot, write it to disk, and then use that snapshot to instantly turn on the machine again, turn on the program again, and skip all the initialization. It'll just go straight from 0 to fully configured almost instantaneously. And this is a technology that you can support on Linux. It only works on Linux, so I'm not going to show it to you here because it takes a lot of time. But it's really good if you're trying to do like a Lambda or Knative or scale to 0. This is phenomenal, and it requires almost no changes to your code. You run the program, take a snapshot, save that to disk, move that to another computer, and then use that to start up the same program instantaneously. And in Spring Boot 3.2, we have support for Project CRaC. So that's part 1. The other option, and by the way, when does that come out? You're right, next Thursday, 3.2. Thursday, okay, 23rd of November. So the next thing that you might want to do is to take advantage of native images, GraalVM, right? GraalVM is an open JDK distribution with extra utilities for native compilation. And so we're going to use that here. We've got support for it in Spring Boot 3.0, actually. So we don't even have to do, it's already been there for a year now, right? But I'm just going to show it to you. So skip tests, native compile, and we're just going to let that run in the background. And the problem, of course, with this is that it does take a little bit of time. And that's my least favorite part of this process, is that it does take a bit of time, even on my fast machine. And so now I finally understand this famous cartoon, this XKCD cartoon. The #1 programmer excuse for legitimately slacking off is, my code is compiling. The boss says, hey, get back to work. And the programmers say, oh, code's compiling. Oh, okay. Carry on, right? I get this joke now. I don't want to get this joke. I don't want to, but I do now. I thought this is just the C++ people, and it just makes me very sad. And eventually, I get very bored very easily. I do these long-running compilations, and I'm sitting there waiting for the compilation to finish, and I start to hear music. When I'm bored, I'm just sitting there waiting. Oh, I get so bored, and I just hear music in my head, like elevator music. And I said, gosh, wouldn't it be great if everybody could hear elevator music? And so I went to Oracle. It doesn't hurt to ask. So I went to Oracle and I said, hey, Oracle, please play elevator music during the native image compilation process. And I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do. I really do. I appreciate their work. They're amazing. And I got some great responses, including this one from our friends over at Red Hat, Andrew Din. He's a distinguished engineer on the Red Hat Java team, OpenJDK project reviewer, Byteman project lead, a GraalVM developer, etc. Really amazing. And he said, please, can you make it this elevator music? This is elevator music that from the 1990s Pierce Brosnan movie, the James Bond movie called GoldenEye, that had a video game on the Nintendo 64, and the Nintendo 64 released a soundtrack album, and then this is one of the tracks on that soundtrack for the video game, for the movie. Okay, I'm not going to play it for obvious copyright reasons, but it's pretty good. Pretty good. I like that. Somebody else said, I'd add that using beeps in general, not only for native image, really helped me to reduce development time. Yeah, that's a great idea. I mean, even my stupid microwave will make a ding sound when it's done cooking. Why can't my compiler do that, right? That's a great idea. I like this. Okay. And then I got this one. Thank you for the feature request, Josh. And this is from, by the way, Fabio Niephaus. He's a researcher on the GraalVM team at Oracle Labs. He's a doctor, one of my favorite doctors, along with Doctor Who, Strange, Seuss, Subramaniam, Sire, DeVolder, and Pollock. And he said, thank you for the feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Yes, okay, I like this. Go on. Anyway, he continues, I have prototyped the -- JoshLong mode. So friends, here's what that would look like, right? You're going to run the native image compiler, and then you're going to say -- JoshLong mode, pass in the class that you want to turn into a native image. It would print out that that there's music playing to, and it's brought to you by JoshLong. I'm JoshLong, by the way, and that's great. But this is a picture, so you can't hear the music, people. But don't let that stop you. You should imagine that there's music right now. Okay, so anyway, it'll print out the text, and then you'll hear music, and then you're kind of wondering what's going on, and you're still waiting, but at least you got lively music. Maybe you want something nice to look at. So then it'll show you this, right? And I think that would be a really good addition to the compiler. I'm sure that it'll get merged anytime now. I forgot what we were talking about. Oh, right, the compilation. Yes. Okay, so that actually, oh, this is awkward. That finished many minutes ago. That is very bad. Okay, so we took a long time. Sorry about that. So let's go ahead and run the binary. Okay. Service, it's 86 megs. That's everything. I don't need the JRE. I don't need anything in the class path. That binary is it's a statically linked self-contained binary that will only run on Mac. And I can build on Linux, and I can build a binary that only runs on Linux. And remember, same if it's architecture specific as well. This won't work. This probably won't run on Intel Mac, for example, because I'm using Apple Silicon at the moment. So okay, native binary, boom. I started it up, but of course there's a port conflict because my existing program is still running. Start that up. Here we go. Okay, now it's saying, oh, you forgot to configure the database, and that's true. So let's go over here, friends. Desktop. Talk, and you can see I've got this this script here, and what that's going to do is it's going to create credentials, environment variables as credentials as environment variables, and then run the binary. It's going to talk to a database with username, password, and schema name BP. Well, that database, I have to start it up, right? Remember, before Testcontainers was doing the work, but now I actually need something real to stand up. So I'll say docker compose up. It's up and running, okay, and then I can do run. Boom. All right, so the program with 100,000 threads started up in 0.116 seconds, and you can see we got Project Loom, so we got great scalability. It's super lightning fast, but much more importantly, certainly for me anyway, because remember, you can use Project CRaC if all you care about is startup time. But for me, and by the way, the startup time on Project CRaC is usually even faster, right? It might be 0.05 seconds. You might get like 50 milliseconds instead of 100. But what I care about instead of startup time, because this is a stateful, long-running program, so who cares? But what I care about is this. This is the process identifier. So I'm going to look at the RAM that it's taking, and you can, resident set size. Oh, I created a 100,000 threads. That's why. But normally, if I just create 10,000 threads or something like that, let's see if we do that again. Yeah, normally this is a little embarrassing. If I normally create just a regular amount of threads, 10,000 or 1,000, this is normally just going to be, maybe 100 megabytes of RAM. You know what I'm saying? And in fact, if I don't create threads at all, if I just use a regular app, it'll take 100 megs of RAM. So this is a very, very good number. But this is, by the way, divide this by 1,000. I should say this is the resident set size is measured in kilobytes. So divided by 1,000. So the number is actually 483 megs of RAM. And that's with 100,000 threads, right? Each of which has stacks and memory and all that stuff. Okay. So now, my friends, we've got applications that take a tiny fraction of the RAM that they would have taken before, a very, very small, like 10% or 5% of what you would have normally spent for the equivalent program. It starts up lightning quick. We can use Project CRaC or GraalVM. We've got the nice fluid DSLs, the REST client, the JDBC client. We looked at declarative client interfaces. We looked at Project Loom. We looked at data-oriented programming, and we've just begun to scratch the surface. We haven't really looked at everything, but I'm afraid, my friends, that we're just about out of time. So I want to say thank you so much for being here today. I know there's a lot of choices for you, and you could have been anywhere, but you chose to hang out with me, and I really appreciate it. Happy Thanksgiving to those of you who celebrate, and I appreciate you. Have a great weekend and a great day.
Thank you, Josh, very much. It's just amazing. And as you hear during compilation time elevator music, I think we can listen carefully and listen these applauses which comes through the air from all around the world, from our audience to you. Thank you very much for being today on JavaOn Conference.
And I really want to read one single comment from our comment.
Okay.
It's like we're watching God playing with their own toy and enjoying every bit of it. This is a fantastic comment.
Thank you very much. Yeah, thank you. Spring is it's if I can do it, anybody can do it. It's amazing, So
yeah, that's super awesome. So Josh, thank you very much. We don't have a lot of questions. Basically, I think people just amazed and running, changing Java version to 21 if they haven't did it previously.
Yeah, and if you have questions, friends, Java 21. That's Java 21 and Spring Boot 3.2. But if you have questions, again, Starbucks fan, and here's my email, josh@joshlong.com. Reach out. I'm happy to help, happy to engage, happy to talk.
Yeah, and I can confirm that I wrote a couple times mail to Josh and he responded. That was just amazing for me as well. So Josh, thank you very much. Thanks for being on JavaOn Conference and have a good day. It's on the morning for you. So thank you very much.
Bye.
Thank you.